So what we're going to study today is transformations of graphs. And so I gave you a handout on this, but I'm going to kind of sort of talk you through it. And I'm actually going to use the same examples as what I typed up. But for ease of use, for the most part, I'm going to use y equals the square root of x. So we learned in the last section that roots are short and wide, or they're more horizontal than they are vertical. So this is still increasing for its entire life. It's just going slowly. And then a square root or an even root will start at the origin, and then it's going to shoot off to the up and to the right. Okay. So it's just going to be easier to see this. And one of the things that I want you to notice is, for the most part, in fact, I'm trying to think, I don't think there is one. The 0.11 is pretty much on every single parent function that I've given you. Okay, so we're going to use that information in a second when we stretch and compress, because having the 0.11 will let us know if it has been stretched or compressed. So for instance, the 0.11 is on this graph. The 0.11 is on a parabola. The 0.11 is on your identity function, which is a diagonal line. The 0.11 is on x cubed and is on the cubed root of x and is on absolute value and step function, all that kind of good stuff. So 1 is going to be a really, really good indicator as if something has stretched or compressed or not. So just notice that we like the 0.11. So one of the first things we want to do is we want to flip things. So if I want to flip things, sorry, if I want to flip things, I am going to put a negative out front. So a negative out front is going to flip this thing vertically. So it's going to go from up and to the right to down and to the right. So what that will look like is I've got my parent function, which would be like this, but now I have flipped it. So what it is it's an x-axis reflection. It's kind of like this is water, and this where it was is now reflected down into here. So a lead coefficient that's negative is going to be an x-axis reflection. So that's one thing that we want to look for. All right, so another thing that we want to look for is a horizontal reflection or a y-axis reflection. And that's going to occur when the inside or your x is negative. So notice up here, the x is not negative. This says negative what? Square root of x. This one says negative x. So because this says negative x, that's going to be a horizontal reflection. So instead of being up this way, what it's going to do is it's going to reflect horizontally. So horizontally means I'm going to reflect it across the y-axis. And so now it's kind of like a mirror. So it was going this way, but now it's going this way. So again, pay attention to what's negative. If it's just a negative out front of whatever your function is, it's going to be an x-axis reflection. If it's a negative attached directly to the x, that's going to be a y-axis reflection. So I'm going to call this y-axis reflection. So I can flip up and down, which is this one, or I can flip side to side, which is this one. So now I'm done flipping. Okay, now I can stretch or compress. So these are reflections, and now I'm going to stretch or compress. So if I have a vertical stretch or compress, and this is where this 1 is going to come into play. So if I want to stretch it, then I'm going to have a coefficient. So I'm going to use my square root of x again. So there's my square root of x, and he travels through the 0.11. Well, if I want to stretch him, that means I want to make him taller and skinnier. Okay, so kind of like taking this thing and just pulling it up like a wad of gum, it's going to get taller and skinnier. So for instance, if I put 2 root x, that's going to make this thing go up taller this way. So notice instead of 1, this is now going to be at 1, 2. Okay, that's going to be at 1, 2 instead of 1, 1. So 1 is kind of going to be our anchor to determine if we have stretched or compressed. So notice he's taller. I didn't change horizontally, but I did double up vertically. Okay, so this is a stretch. What if I want to compress? My compress is going to be a fractional coefficient, and I need to be a little bit more specific than that. So this time, instead of going through 1, 1, I'm actually going to flatten it, and it's going to go through 1, 1/2. So this one is 1, 1, which is where it started, but then I stomped on it and squished it. Okay, so here's the question. How do I know if it's a stretch versus a compress? So a stretch is going to be bigger than 1. A stretch is bigger than 1. A compress is going to be between 0 and 1. Okay, so stretch is bigger than 1. Compress is between 0 and 1. In other words, it's a proper fraction. This can be an improper fraction. So we're going to keep it basic. We're not going to go into scary stuff. But just know if it's an improper fraction, so 2 over 1, it's going to be a stretch. If it's a proper fraction where your numerator is smaller than your denominator, then it's going to be a compress, like it got stomped on. So now I know how to flip both ways, either topped vertically or horizontally. And now I know how to stretch vertically or compress vertically. Okay. The next thing I want to look at is, notice for one thing, nothing has moved. I'm still anchored at every single one of these. I'm still anchored at the origin. Still anchored at the origin. So now what we want to do is start moving things. So if I see any addition, subtraction, if I see any add or subtract, that tells me I'm going to move. So if I'm going to move up, down, so move up or down, that's going to be a number that's added or subtracted to the function itself. For instance, if I've got y equals the square root of x, look, there he is, okay? And then if I say, all right, y equals the square root of x plus 4, what I'm going to do is pick up this root, and I'm going to march upwards 4 units and drop it back down. So instead of hitting at 0, 0, it's going to hit at 0, 4. Okay, and then the rest of it just stays the same because that's all I've changed. So notice I've got a plus or minus hanging off on the end. So once we start organizing these things, I want your constant to be on the end. So whatever you're adding or subtracting needs to be on the end. Now what if I want to move it left, right? And this is the one that is slightly confusing because first of all, I need to look at where it is located, where the plus or minus is located. So in this case, it's going to be inside with the x. So notice I do have addition, subtraction, but notice it's clumped inside with the x somehow. So in this case, it's clumped underneath the radical. It may be clumped in a denominator. It may be clumped in an absolute value symbol, okay? But it's clumped inside with an x. That tells me left, right. Now, instead of moving to the left 3, so this one you do what it says literally, I would go up 4. On this one, you're going to do opposite. So instead of left 3, I actually need to go right 3 units. Now, why is that? Because if I plop in a positive 3, which is right here, 3 minus 3 gives you a y coordinate of 0. So on this case, you move opposite of what you think. This is the one time that you move opposite of what you think. So now what we're going to do is start applying some of this stuff. So the first thing we want to know is, what is our parent function? So I'm going to kind of give you a list. What is your parent function? So your parent function, you're going to identify by telling me where is your variable. So for instance, is it under a radical? Is it in a denominator? Is it in special brackets? Where is it? It may just be sitting there, okay? It may not be any place special, but I want to know where is your variable. The second question I'm going to have is, does he have an exponent other than 1? So other than 1. So what's the exponent on your variable? Is it something other than 1? And that's going to be an indicator of what my parent function is. The next thing I need to do is identify transformations. And when we identify the transformations, we're going to identify if it's been reflected. We're going to identify if it's been stretched or compressed, and we're going to identify if it has been moved left, right, or up, down, or both. Okay, so that's what we're going to start looking at. And remember, for the stretch or compress, what we want to look at first is the fact that it was at 1, 1. Pretty much every single one that I've given you. I'm trying to think if there's one that I gave you that's not going to hit at 1, 1, and I don't think there is. But if it doesn't hit at 1, 1, where does it hit? And that's going to help us figure out what the stretch or compress is. So that is our summary, and then we're going to come back and we're going to do some examples.